Hey, okay. So, okay. Right. Um, we're learning Golang. So, it's a programming language. Sort of read up to this far, and then I'm like, sure, let's let's just stream me learning this. Okay. Right. The goal by the end of this stream is to be able to read through all of this, read through how loops work, which shouldn't be that difficult. Variable scoping also shouldn't be that difficult. And then we're going to do this big exercise here. So get through all of that up till page 50. And then I'm going to try like complete this entire book. So yeah, that's the goal for today. To finish this one exercise and then eventually complete the book. Let's see. Right. I don't have Go installed as of yet. So I'm still just gonna work with this Go playground, which should suffice. Do you put commas? You don't put commas. So just that gives us access to numbers. Right. So that killed the so with quick format, yeah, it kills the math RN because I think if I remember correctly, Go doesn't allow you to use packages if you don't actually have them in the program. So if we were to just run this directly, it would give an error. It would just automatically kill it for me. Okay. Cool. Let's see. Let's clear variable random number. How does random number work? Okay, I can just do that. So this will give a random number from 0 to 9. And then I can print a random number. So if I run this, I got 0. Let's see what I get next. I get 1, I get 3, 8, and so on. Cool. Now, the thing is, I'm very fond of functional programming, or at least that sort of paradigm. So I'm gonna try well, let's just ask ChatGPT here for a bit of help. In the programming language Go, because I don't want it to misunderstand, Go is a very common word. Do you create external function that creates an output which you can use in the main function? Okay, so if I just do sort of return, okay, so if I just do that and then return random number, can I just do print test function 1? Ooh, okay. Now let's see what we did wrong. We have to specify the return type. Ooh, nice, okay. So we can do functional program. Right, loops and branches. Let's see how if-else statements work. When you read Choose Your Own Adventure books, you'll come across choices like this. If you walk outside the cave, turn to page 21. Do you walk outside the cave? In Go, your answer can be either true or false to constants that are already declared. You can use them like this. Take the blue pill. Walk outside. Okay, for example, the following listing uses the contains function from the strings package to ask if the command variable contains the text outside. It does contain that text, so the result is true. Okay. Seems okay so far. Let me just see. There are like very many different print functions. So there's println, and then there's something else. There's just regular print. Okay. What is the difference between fmt.print, fmt.println, and I think there's printf. Yeah, printf. Yeah. Tprintf. Oh, okay. Alright, I get the gist of it. Alright, now let's go back to loops and variables and loops and branches. Branching with if command equals go east, then print this, else if command equals go inside. Alright, so if something equals something, then we put our command in here, we have else if blah blah blah, and then we put our command in the bracket, and then okay. So let's see. Let's try to implement that. So we created a variable called random number. Now create another variable. Let's do. Wait, if I do 1, does it give 0, 1? So it's just a random 0, 1. So we get 0, 0, 0. We always get 0. So it's probably 2 that we want. So you get 2 choices. So you get 0. Bro, it's still okay. We finally get a 1. Okay. Get a 1. Get a 1. Get a 0. Okay, cool. So now we want to declare another variable, some text, let's say, and we get hello. Then basically if random number equals 1, then we'll replace text with konnichiwa. And then now we just have to return text. So we get either a hello or a konnichiwa. So this is not an int anymore, I'm just write string here. Oh, okay. So let's do that. So get a hello, get a hello, a konnichiwa this time. Hello, hello. Okay, that's cool. Nice. We're slowly getting there. So is this just string? Okay. Any year that is evenly divisible by 4. But not evenly divisible by 100. So divisible by 4, not divisible by 100. This is an OR, right? Okay. Branching. Let's see. So this is just a better if else, it looks like. So let's just try use this, I guess. So instead of this guy here, so we can just do vartex, right? Or vertex str. Okay, declare a variable. see. Constants and variables. Okay. Declare variable and type without giving specific value. I think you can do that, you know, like I've watched videos and stuff. Okay, so yeah, that does work. Okay, so var text string. So it'll just create, I think a default string is just an empty string, so we'll just return like nothing. So if you just run this, oh yeah, it's not used. Oh, str string, okay. How do we comment again? Is this a comment? Okay, that's a comment. This is a comment. What? Okay, so it'll still work, it'll just print like nothing. Now we'll do cases, which random number. So switch, and then we'll do cases. So how's that work? So case 0, and then something, right? So case 0, our string will be hello. And we can have case 1, our string will be konnichiwa. If I can type these, okay. So return, oh, not string. Text, and return text, right? So this should just do the same thing as what we did previously, except it's maybe neither. Okay, cool. So that's how the switch works. We could do like this. Fall through to the next case. So let's see how this works. So it'll skip this because room is not lake. It'll run this because room is lake. So it'll print the ice seems cold, which is what we see here. And then it'll fall through. So it'll, I guess that means automatically that you'll run the next case even though it's false. Doesn't matter if it's false or true, it'll just run the next case. But I don't really know why you would use this though. Just use to execute the body of the next case. Be better if okay. Might be better if I there we go. I'm super transparent now. So you can see the code that's behind. Or maybe it's better if I just um let's flip vertical. Nope, that's not the flip I want. Oh. God, I look kind of weird flipped the other way around. Yeah, I look super weird. I'm not made to be flipped. It'll flip me back. Oh god, I keep... Okay. Whatever, I'll just keep it like this. And you can just read behind me. Right, what are we gonna do? For loops, okay. Right, let's do a test function 2. This will not return any value, it'll just do stuff. And the stuff it'll do is... whatever this is. So... var count equals 10. 0. Print, say, print ln count. The variable count, not the string count. Time dot sleep. Time dot sleep. Time dot second. So it'll wait a second, I guess, before running again. And we'll reduce count by 1. T dot print lift off. So running this function, so we can just do function 2. So it'll say hello or konnichiwa. Do 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then lift off. Right. Ooh. Okay, what's wrong here? So you have time here. Okay, sleep has to be capital. And then, I guess, oh, test function 2 instead of function 2, okay. Look at that. 3, 2, 1, lift off. Okay. So let me just check my understanding. If I just use print here, then it'll just, all of these won't be in the same line. Won't be in different lines, they'll be in the same line. So it'll be like 109,800 something, whatever. Right, let's just see. Yeah, everything will print on the same line now. I think liftoff will also be in the same line. Yeah, liftoff will also be in the same line. But any normal print after the liftoff will be on a new line. Yep. Okay. Let's see what happens if we don't use sleep, so we don't need time. How fast will it be? Will it just be like instant? Yeah, it'll just be instant. Okay. Right, let's get rid of this. Go back to reading stuff. Right, so loops and everything, I think we've got the gist of that. Let's see how this works. So it'll print, okay, so it'll print 0, and then degrees will add by 1. If 1 is greater than degree. If 1 is greater than 360, which it isn't, so it'll run. Wait, what? So degree is 0. It'll add by 1, so degree is 1. 1 is greater than 360, which is false, so this whole thing won't run. And we'll just get nothing, question mark? Hang on. Wait, what? This doesn't work. Okay, wait, let me try this out then. So yeah. Do a different test function. Doesn't output anything. So var degrees equals 0. For oh, okay, there's a for loop. Okay, so this ends here. Okay, wait, let me try to understand it. Alright. So that's the for loop. fmt dot print and degrees plus plus if degrees is greater than or equal to 360. I didn't see the for loop here initially, so yeah, it'll just print 1, 2, 3, 4, 5, 6 all the way up till 360. And then once it hits 360, whatever's inside here will run. That is, it'll set the degrees back to 0. And then let's set the degrees back to 0. It'll run this thing, so either the loop will break or it won't. If it breaks, then the program stops. If it continues, then we just repeat this for loop over again. So it'll print 0 to 360 a certain number of times. Right, let's run this, I guess, then. Test function 2. So if we run this, so we get, actually this is maybe too much, let's do 10. So, right, so the program exited there, so it only ran once. It only ran once here again. It ran once. We're getting pretty unlucky here. It ran once. Oh, it's only running once. That's not what's supposed to happen. Now it's run twice. So yeah. It can run up to a total of... well, it can run technically forever if we're super unlucky. So yeah, this one ran twice. Okay, so if we add like, if we make this 5 for example, we'll get more runs on average. So yeah, now we get 1, 2... oh, this is still 2. This is still 2 runs. Okay, now this is a lot more. Yeah, okay. Right. I understand now. Okay, cool. Lesson 4. or it'll be the thingy thing. The exercise, the big exercise. Right, I'm going to go piss. Start. Alright, let's go. Cool, right. When the variable is declared, it comes into scope, or to put it in another way, the variable becomes visible. Your program can access the variable as long as it's in scope, but once a variable is no longer in scope, attempts to access it will report an error. One benefit of variable scope is that you can reuse the same name for different variables. Can you imagine if every variable in your program had to have a unique name? If so, try to imagine a slightly bigger program. Wait, one benefit, you can reuse the same name for different variables. Okay, sure. Scoping also helps while reading through code because you don't need to keep all the variables in your head. Once a variable goes out of scope, you can stop thinking about that variable. In Go, scopes tend to begin and end along the lines of curly braces. In the following listing, the main function begins a scope, and the for loop begins a nested scope. The count variable is declared within the function scope. So this guy, I think, yep. And is visible until the end of the main function. Whereas the num variable is declared within the scope of the for loop. After the loop ends, the num variable goes out of scope. So if you try to say print num after the scope ends, then we'll report an error for any attempt to access num after loop. Short declaration provides an alternative syntax for the var keyword. The following two lines are equivalent. It may not seem like much, but saving 3 characters makes short declaration far more popular than var. More importantly, short declaration can go places where var can't. The following listing demonstrates a variant of the for loop that combines initialization, a condition, and a post statement that decrements count. When using this form of for loops, the provided order is significant: initialize, condition, and post. So initialize, so count is 10, and then this checks if this is true, then it'll run one loop. It'll run this once, and then it'll decrement it by 1, and then it'll do it again until this condition is no longer satisfied. Okay. Cool. Without short declaration, the count variable must be declared outside of the loop, which means it remains in scope after the loop ends. By using short declaration, the count variable in the next listing is declared and initialized as part of the for loop and falls out of scope once the loop ends. So we can just use the short declaration here. Okay. Right, so that's good. Because count is only necessary for this part of the program, so it's not necessary to have it outside of the scope beyond this bit of the code here. Okay. So this will make it so that num is part of this entire scope, I guess. Each case has its own scope, so this is also its own scope. So yeah, you could declare the variable day, and then you could declare a variable day again without there being any issues, so that's cool. Three independent day variables. Yep. As each case ends, the day variable declared within that case goes out of scope. This is the only situation where there are no braces to indicate scope. Okay. The code in listing 4.6 is far from perfect. The narrow scope of month and day results in code duplication. When code is duplicated, someone may revise the code in one place, but not the other. Sometimes code duplication is justified, but it's considered a code smell and should be looked at. To remove the duplication and simplify the code, the variables in listing 4.6 should be declared in the wider function scope, making them available after the switch statement for later work. It's time to refactor. Refactoring means modifying the code without modifying the code's behavior. The code in the following listing still displays a random date, though a narrower scope often reduces the mental overhead. Right. It's time. It is time. Welcome to the first challenge. Your challenge is to write a ticket generator in the Go playground that makes use of variables, constants, which, if, and for. You should also draw on the blah 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 blah. to align text and to generate random numbers. When planning a trip to Mars, it'd be handy to have ticket pricing from multiple space lines in one place. Websites exist that aggregate to blah blah blah. Well, we'll start by building a prototype that generates 10 random tickets and displays them in a tabular format with a nice header as follows. The table should have 4 columns. The spaceline company providing the service, the duration in days for the trip to Mars, where the price covers a return trip, the price in millions of dollars. For each ticket, randomly select one of the following space lines. Use October 13, 2020 as the departure date for all tickets. Mars will be 62 blah 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 kilometers away from Earth at the time. Randomly choose the speed the ship will travel from 16 to 30 kilometers per second. This will determine the duration for the trip to Mars and also the ticket price. Make faster ships more expensive, ranging in price from 36 million to 50 million. Double the price for round trips. When you're done, post your solution to the Get Programming with Go forums if you get stuck. Alright, we can do the first one pretty easily. Randomly select one of the following space lines. So that is just basically, so we have, okay, random int, so 2 randomly chooses between 0 and 1. So 3 randomly chooses between 0, 1, and 2. We'll add a case for 2. So we can just say, oh, we can just do this, right? So that'll get rid of that. And I guess declaring text as a string is fine here. So this will be airline. And then what were the possible airlines? Space Adventures, SpaceX, Virgin Atlantic. Space Adventures, SpaceX, and Virgin Atlantic. Alright, so let's just copy a bunch of these guys just to see that we're getting. So SpaceX 4 times, Space Adventure once, Virgin Atlantic another time. Let's run it again. Alright, cool. Yeah, it looks pretty random. Cool. So we have something that randomly chooses an airline. That's good. Now we need something that... Okay. Randomly chooses the speed 16 to 30. So that'll just be I mean, it's kind of overkill to write a function for this, but whatever. Speed will be an integer. So var speed equals rn dot int n oh shit, let me think. So 16 plus what gets 30? 16 plus 14 results in 30. So we want 14, wait no, yeah, 14 here and then plus 16. Let me think. So the minimum this can be is, so this can give 0, and then 0 plus 16 is 16, so we get that. And then the maximum this can go is, let me think, 13. And 13 plus 16 is not correct, so we'll have to make this 15. So this will generate numbers from 0 to 14. So 0 plus 16 is 16. 14 plus 16 is 30. So that should work. Now we just have to do return speed. Or can't we just do return this? Right, so print, so fmt dot println airline, and then now we'll print the speed. And we'll print the speed a few more times. Just to see the range of values that we get. Cool. Let's run it again. Just to make sure that we don't get any weird values. It should be 16 to 30. And that looks, the values there look normal, so that's good. Okay, so now we want to check how many days it'll be, but I guess the days will have to be initialized in the main function. Or we could make a... Okay, no. So we could make a func ticket, and it'll generate a ticket, but the ticket will be a set of values. So it'll be a list, except we haven't even like studied lists yet in this thing. Lists in Go, different where values have different types. Function that both a string and an int. Now I implement that. Oh, okay, cool. So I don't need to like make a list, okay. Awesome, okay. That's beautiful, that's beautiful. Okay, so we have a ticket generator, ticket gen, I guess, ticket gen. So it'll print out the informations of the tickets. So first, it'll print out the airline, and then next it'll print out the speed, which is an integer. Right. So right now, all it'll do is so yeah, what we can do right now is just make it return airline and speed. And then I will do sort of airline speed, and that'll be ticket gen, and then I will do print ln, no, fmt.println. Can do airline and speed. So let's do a okay, please work, please work. Shit. Huh? Oh, okay. Right. Awesome. Okay, I wonder why this doesn't work though. Oh, it's because... Okay, maybe? Huh. Okay, so yeah. Okay, let's do... Let me just do a little bit of testing here. Let's say we do that and that. This would not run because... Yeah, we set airline and speed as these values, and then now it says, hang on, you're treating airline as if it's a function, but it's not a function, it's a value. So we just replaced the thing here. So now we can't call airline at all. We can't just say airline there. So we just lost access to these functions after declaring these values in ticketgen, because it's replacing the name of the variable. It's replacing the variable itself. The name didn't change, but it changes the value that's inside of the variable, so that instead of being a function, it's now a value. So it doesn't make sense to write this thing. Okay, that's fine. Well, it kind of... Well, so we won't be able to access airline and speed if we choose this naming convention, but that should be fine since we are not planning to use those functions. So yeah. Next we'll get days. So we'll set days var days to equal okay, actually we'll set var airline equals airline var speed equals speed or actually const be better. And then const days equals speed. So what was the... So 6 to... What was it? 6 to... Do you use commas in numbers? I don't think so. So just have the value there, and that's 62,100,000 kilometers. Divide that by speed, and you get the number of seconds it takes. and then you divide seconds by 60 to get the number of minutes. You divide it by 60 again to get hours, and then you divide by 24 to get the number of days. So 60 times 60 times 24 is 86400. So yeah, so we'll have 86400, and then we'll wrap that around. So now we have the airline, speed, and the number of days it takes. So we'll have airline, speed, and then days, airline, speed, days. Let's see. Huh. It's not constant. Sure, I guess, fine. Okay, Virgin Atlantic 1742. Let's test this out again. So let's see. Let's have a calculator. There's six, how many? 6 to 100,000. 6 to 100,000. That's 100,000. So that's how many kilometers it is, and then we have our speed is 17. That's, we get the number of seconds if we do this. And then we divide it by 60 to get the number of minutes. Divided by 60 again to get the number of hours. And then divided by 24 to get the number of days, and we get 42. Yosh. And that's the answer that we got here. Nice. Okay, so that everything checks out. Everything makes sense. They didn't say like round up or round down, did they, for the number of days? No, they didn't say the round up or round down. I'm gonna just round down, I guess. Right, now we need to calculate the price. Faster ships are more expensive. And then, yeah, okay, I'm gonna go to the toilet. But this is close to being done, so this is cool. Right. Right. Where were we? We have to calculate the price. So basically it's just I assume just like a linear function, so you can just go to decimals or something. Okay, so we'll have y equals mx plus c. Right, so you just have to find um, the right function here. Okay, so we want um, blah, blah, blah. So fastest is 30 kilometers, and we want that to be 50 million. So our input is 30, and we want 30 to be equal to 50 million. So we just have to increase c so that it goes up to 50 million. Need to add. Let's just set this equal to 1. 50. So there we go. Oh no, so this is 30 and 30 is 45 right now. So just have to make it 20, I guess. Right, so 30 gives 50. Right? So now we want the lowest speed, 16, to be 36 million. So lowest speed is 16. Sixteen is 36 million. It's already there. Okay, 36 million, right? Right, cool. So our function is y equals x plus 20. So that'll be the price. So price is equal to just speed plus 20. Cool. So that's another int. We get price. What's the... Oh, that's not the price, because we have to double the price for round trips. So... okay. So that's another random number generator thing. Okay. That's round trip. We can literally just make this a boolean, I guess. Or it doesn't have to be a function. You can just say var round trip equals okay, random mean go. Oh, that's pretty smart. Okay. So var multiplier, I guess. Actually, don't make this a boolean. We can make this a... Right, so this will give either a 1 or a 2. So we just have to multiply this. This is a multiplier. And we just have to do this times multiplier. So that gives the price times 2 or times 1 depending on if the trip is a round trip or not a round trip. And then we have var round trip string switch, it's switch, right? Yeah, so switch multiplier. Case 1 case 1 round trip equal, what does it say here? One way or round trip? So if it's 1, it's a one way, right? One way. Case 2 round trip equals round trip. Do we call this better? What's it called in here? Trip type. Okay, so we just say trip type, whatever. Trip type. So it'll randomly pick whether it's a round trip or not. Randomly pick an airline, randomly pick a speed, calculate the days it will take via the speed, calculate the price by adding 20 speed, and then multiplying it by 2 or 1 depending on if it's a round trip or not. Take that 2 or 1 value and convert that into a string so that we can use it to print our ticket. We should be done. Okay, so airline int, and then string again. So days, price, and trip type. So we just have to, it says we have to print 10 of these, right? So we just have to make a for loop basically. This is one of the loops. Run. Shit. Price is not used. Oh, so speed, days, price, and trip type. Alright. SpaceX 2331. And it's a round trip, so that's why we get 86, which is a high value. It's above 50 because it's double the price. Okay, that makes sense. Let's try running it again. Now it's one way, so the price is below 50 million. Okay, beautiful. So now we just have to basically format everything nicely. So there was in lesson 1 or something because there's like nice padding and shit here. So we have to kind of copy that, I guess. Just type padding. Okay, so I'll just copy this for now so that you can see what it looks like. Okay, and then we can go back to the exercise, just page 50 something. Okay, so let's print this thing, the top line. We'll print the top line, we'll print this thing here, and then we'll begin our loop. But first, let's print our top line. So let's see, so let's type spaceline in here. And then days. Okay, so let's see what that looks like. So we have spaceline days. So the numbers here look right aligned, so that's good because the days here is right aligned. If it's a positive value, then that should be right aligned. Right, next we want something left aligned. It's strip type. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do 11. I think 11 would be a good number. So percent negative 11 V. And we'll do trip type. See how that looks like. Oh shit, forgot to add the new line. So spaceline, days, trip type, and then we'll have price, which looks right aligned. These numbers are right aligned. So it's 10, and then percent price is 5, I guess. Okay. Let's see. FMT print F. Now we just have to print a bunch of these values. I don't know the exact number, but well, we'll see. So just a little bit more, I guess. Okay, that looks beautiful. Oh, beautiful, right. Now we just have to copy this, but okay. I wrote airline instead of spaceline because I forgot we were doing space trips for a moment there, but whatever. So, okay, we don't need speed, so we can just like ignore that. Actually, or like we just do, I guess even better is to do this and remove speed here. So airline, okay, no, airline days. Okay, so it returns shit. Where were we? Airline days, price and trip type. So airline days. So it says trip type here in price, so we'll do a trip type and price. Okay, so this should do it once. This should. Oh, it's beautiful. That is so beautiful. Okay, we forgot to add the dollar. The dollar there. Ooh. Beautiful. Maybe 15 is a bit too much here. Let's reduce that to. So we have what, space. I guess Space Adventures and Virgin Atlantic will take like a lot more. Right, now we just have to run the for loop, right? So for count 10. So what was the format again? Yeah, so this one. So we'll do it, wait, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, yeah, this works. So count equals 10, semicolon, count greater than 0, semicolon, count minus minus, and then bracket, and just put U in the bracket. And we're done. Oh my god. Okay. Let's see this in action. Ooh. Beautiful. Except there's this weird thing here with Space Adventures. So I guess, wait, something with the padding. Or maybe. Okay, if we change this to a 5, I think the issue should be solved. Nope. Okay. Kind of sucks, I don't like that. change this to a 16. Oh, nice. Okay, let's reduce this to a 4. And then add 1 to the trip type. I think that might make it look a bit better. Yes, it does. Oof. Okay. Maybe actually instead of 4, maybe a 3. And then we should add a bit more a view. Oh, look at that. Look at that. Beautiful. Okay. I said we'd be done, but I guess we'll install Go and actually just try run this in my computer. And we'll see how that looks. Is what we'll do now. So yeah, I'll just download Go. Microsoft Windows. How big is this? This is 68.7 megabytes. Right. Oh. I don't know. Was my code good and efficient? I have no idea. Let's just ask ChatGPT to rate it. I'm shadowing function names with local variable names, which is something that I did point out. So yeah, this can be pre-computed as a constant, I suppose, but that's fine, whatever. Without this, the random sequence will be the same every time you run the program? No, it's not. If I run the program again, we'll have 26 one-way 47. We'll run the program again. Now it's 78. What are you talking about? Ooh, they have a struct type. Look at this. 8 out of 10, 7 out of 10. For my first time writing a Go program. Not bad, not bad. Alright. Installing Go now. I should remember to switch OBS screens. Okay, so this book basically doesn't tell me to install Go at all. It says that you can just do everything from the Go playground. So it basically doesn't tell you anything like about how exactly you install and stuff like that. I'll have to look up another resource to be able to get that data. Okay, so Go is finished. So let me switch to a display capture so you can see everything. Wow. So yeah, let's do command prompt Go version. What? Oh, I think it's capitalized, is it not? No? Are? Okay. CMD Go version. Let's try run as administrator, maybe? Go version. Nope. I'll have to add Go to the path. Yeah, let's see. It's just bin. I think it's just bin, right? So it could be in. Go is not in here. So Go is okay. I'm not exactly sure how to edit. I think go to the system path. Okay. Yeah, okay, let's see. System variables. Environment variables. A new Golang bin. So Golang is there now. Okay, okay. Let's try again. Go version. Yeah, the reason why I am skeptical. Do I have to put the dollar? No. It's because I tried doing this for like other things, but it didn't really work if I tried to edit the environment variables. Okay. Echo percent path percent. See, I did. So I do have the path for Go installed here. So Go. That's weird. Go is in. Does not do anything. Version gives. Go is not recognized. So yeah, it is in the path over here. Make sure you see C go bin. Yep. So yeah, it is there. Wait, do I do go.exe version? Oh, there's a trailing double quote. Okay, okay. That might be. That might be why I've been. Okay, okay, okay. Where was that? So it's in system variables. So it was Conda that's doing the. C users and Anaconda. Where's Conda? Oh, Go path is here. So it did install the path, but it's just that because I have the thingy thing. Wait, where is it? So that's Python 312, Python 312, blah 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 blah. I can't find conda bin here at all. Cannot find the entry in the system/environment variables. Is it here? I guess the only thing I can't see is this very long thing here. Oh shit. Okay, this does have a lot of things in it. Okay, okay. Does it have it doesn't have conda though. Okay, let's look at this one now then. It's still not here either. Where the fuck is conda? Where the fuck is conda? Oh my god. whatever. Did you choose PowerShell? Okay, conda bin is in machine. Is in the machine path. Let's find conda bin. Oh, it's there. It's there. It's there. Look at it. It's there. Okay. Right. So conda bin is there. How do we fix it? So it's in system variables. But for some reason, I can't find it anywhere in here or wherever. So we have VS Code, Python, Mictex, and Go. So Python, Mictex, and then directly Go. So it doesn't, I can't edit this because it doesn't exist. It should be somewhere between here and here, but it's not there. How the fuck can I edit it? Okay. Run an admin PowerShell. PowerShell. Run as administrator. Oh my. This is old path. And this is new path. Can I print new path to check to see if it works? Can I print new path first to see if it is correct? Because I don't want to like screw anything up here. Okay, so I can do that to print. So you have conda bin, but we don't have the quotation, whatever. So that's good. But it doesn't have the semicolon. So yeah, Yeah, we have a semicolon and then C users, blah blah blah. So over here we don't have the semicolon. We just have C directly. So yeah, I think we have to include that in. So let's try this again. So old path is this guy, and new path should be that. Okay. And then now let's write new path. And there the semicolon is there. Okay, let's write old path and just see the difference. That's old path with the quotation mark there, which is wrong, and my computer hates that. Okay, so everything looks the same between new path and old path, with the exception that this quotation is removed because we just have one character missing, which corresponds to the one character being removed here. So everything else is the same, which means that we're okay to replace shit. Okay, so replacing things is just okay. We just have to do that. Okay. Cool. So, run this to update the system path, which we did. So verify the fix. Let's read our path, and then conda bin doesn't have the quotation mark again, so that's super good. Now we just have to close the terminal and open it again. Close you, open it again, and Go should work. Go version. Fuck yeah, let's do this. Let's go. Okay. I've never been so hyped because, like, whenever I install something, like, sometimes it just doesn't work because I try to add it to the path and then it just doesn't work, so I have to, like, come up with these workarounds. But now I know what the problem is and it's fixed, and I won't ever encounter the same issue again because ChatGPT saved me. Okay, that's cool. That's cool. Anyways, right, so we want to turn our thing here into an actual program on my computer. I think we can go go tutorial. Was it this?
Hey there, gang, and welcome to your very first Go tutorial. Alright then, so first of all, what is Go, also known as Golang? Well, according to the Go website, Go is a fast, statically typed, compiled language. But what does that all mean? Well, first of all, compiled means that Go is compiled.
So let's go to the setup portion.
Well, now I have Go. I'm going to install all of these right here. And I'm also going to click on this one, install all. ELS. Go ahead over here, Go support in, open up a folder, just an empty folder in VS Code. This is where we're going to do all of our work. Alright then, so there is a package that you should install first of all for Go support in VS Code.
Okay, Go support in VS Code. Alright. Let's do... Hold on. Go projects. Um, exercise one, whatever. So we'll just have to open VS Code here. Fine. Oh, I thought. Okay. So this opened not in the folder that I want. Right. Okay. Okay, let's see.
And that package is just called Go. So type Go right here.
That package is just called Go. So type Go right here and bang, bang, bang.
And it's this one. So click on install first of all. That should install pretty quickly. Once it's installed, go ahead over here and just create a new file, and I'm going to call this test.go. So it
Alright, new file, test.go.
has a .go extension and press enter. Now, when you do that, you're probably going to see these pop-ups right here. So what I'm going to do, where it says GOPLS, I'm going to install all of these right here. And I'm also going to click on, I'm going to install all of these right here. And
So it installed GoPLS and static check, which
I'm also going to click on this one, install all. So make sure you do that as well to get the full support inside VS Code for Go files. And then once that's done, VS Code is ready and set up to work with Go files. Now, before we quit this video,
so it only did install two things. Although over here it looks like a lot of things got installed.
I just want to show you how to access all of the course files. So at the right over here on my GitHub repo called Golang Tutorials, the link to this is going to be down below the video. And every lesson has its own branch in this repo because every lesson has its own code. So if you want to see the code for lesson 10,
Why
for
the fuck is my
you'd go to
laptop
branch
so
dropdown,
slow?
go to lesson 10 to select that lesson, and you're going to see the main.go file right here. All of the code is inside that. If you want to download it, you can go to the
Anti-malware.
and then download a zip file, which is going to include this file and any other files that might be included in different lessons.
Oh my
so
god.
Now all of that intro and setup is out of the way. Let's start writing Go code. Now, if you want to watch
Probably
this
doing a
full
scan or
course without
something.
YouTube adverts, you can do. I've uploaded it to the NetNinja website, which you can find at netninja.dev. So you can buy this course for $2.
Okay, so let's check the Go well, static check is not here, and Go PLS is not here either. Installing two tools at C users rn go bin, but it's not. I don't see it. Installing Go PLS succeeded. Oh, okay, it's doing this. Okay, so it's still running. Go PLS. Let's refresh. And Go PLS is still not there. Even though it said that it's done. Weird. Oh, okay. You're ready to go. Nice pun. So I refreshed, but still nothing. Oh, it's a different directory. C users Aaron Go. Ah, so okay. $169 MB. Oof. I have so many junk files. Okay. Alright. So we are ready to go. We're ready to go. Alright, what next? Your first Go file.
Alright then, so let's start by making our very first, very simple Go file. So up here, new file, and I'm going to call this main.go. Since this is going to be the main application file. Now you don't have to call it main.go, but you'll find a lot of developers call their entry file something like this. And inside this file, I'm just going to paste in a little bit of code, which is pretty much the demo code from the Golang website. And it's going to allow me to explain the basics of how we write and run a Go file on main function in the application. We don't have one in every
Right, so how do we
file
compile?
inside our package. Do these things, one of which is reporting. So this one is called terminal, which you can do by going to terminal and new terminal. I've got a shortcut Control T, which I've set up for this. And then you need to make sure you're in the correct directory where the file is. I'm in the Golang folder, which is correct. And then we type go run to run a file, then the name of the file, which in our case is main.go, and then hit enter. When we do that, Go is going to find this function automatically, and we should see this printed to the console. So let's hit enter, and then, yep, we see hello ninjas.
Right, so that just runs it without compiling, but yeah, okay. Huh. What does... So we have go, roaming, go. So this is where all the action is happening, I think. Okay. Whatever. So go run test.go. Hey, so that's the same thing that we got in the Go playground. So I think compile go. Okay. So go build test.go. We'll turn it into an executable file. Now, how big is this executable file? I wonder. How good is it at where the fuck is it? 2 megabytes. So 2 megabytes to print this shit out. So yeah, we can do test.exe, and I guess that'll, if we just run text.exe, then yeah, it'll print this thing out. But it, oh, we have $100 here, which is why we get weird spacing. So yeah, Perhaps we should increase the space to a 4, I guess. So I don't know. Let's delete you. Change this to a 4 to account for the fact that we might get $100 or something. We'll save it and we'll do go run test.go. So yeah, we can either run it directly or we can make an executable file out of it and then run the executable file. Pretty cool. We got one way 9 out of 10 times. That's insane. Because that's a coin flip, right? That's getting like tails 9 times in a row ish. That's insane. Let's run it again. Yeah, this looks more normal. This looks like an anomaly. Sheesh. The heck is all this? Anyway, we're done. Our first Go program. Nice. Alright. That'll be it, I guess. I'll see you next time. Goodbye.